In this exercise, we're going to do a model bridge and then put it into a frame like this to test it, see how much weight it can hold. I made a mistake though on my design in that if I look at this from the front view in a section view, I really intended for as the weight pushes down on here that this part is up against this edge, and so I need to redesign this in some way so that I'm transferring the load over to the side of the test frame instead of having it separated by that distance. So that may be a good idea of something that we need to change to improve the design. Before starting a project, I first create a folder in which to save all of the files, and I create an Inventor project file, IPJ, to point to that folder so that all of my part files and my assembly files are saved in that same project. I created a new project and I named that, in this case, Wire Bridge Fall 19, and then I'll start the bridge skeleton. Now I named this bridge skeleton revision 1. I will start a new sketch on the XY plane and I'm going to draw a rectangle below the origin, and the width of the test frame for this is 17.75 inches. So that's the dimension I'm going to do for this rectangle. Now I'm going to hold off on dimensioning the height of it for now. I'm going to do a coincident constraint between the midpoint of this line and the origin. I'll then draw a vertical line out in space, and I'm going to do that 2 inches tall, and I'll do a coincident constraint between this line and the origin. So that line turns dark, it's fully constrained, and then I'm going to do a 3-point arc from this point over to this point and up to this point. And when I think about that for a minute though, I realize that I'm going to actually have a piece that extends off the end of this 1/8 of an inch to fit onto the bridge abutment. And so let's draw a lip on here on this end, and I'm going to draw a lip on the other end, and we'll make those two lips equal. And so I'll do equal, this one is equal to this one, and then I will dimension one of those as 1/8 of an inch. And then I'll do my 3-point arc. So I want to go from the end of this lip, make sure you snap to that point, over to the end on the other side, and then for the 3rd point to this arc right here. All of that turns dark, it's all fully constrained. I'm going to change all of these lines to construction, and I'll change this line to construction, and then I'm going to draw another 3-point arc, and I'll just put this one in space to start with, but I want it to the end of this 2-inch line. I want to make these two arcs concentric to each other, so I'll make this arc concentric to this arc, and I'm going to trim it off though at this line instead of over here. So I'll do trim, and I'll trim that piece off, I'll trim that piece off. I'm then going to change this arc to construction line as well. I will drag this point up to the end of this arc, and I'm going to finish sketch. And one additional operation that I want to do is the length of this arc. So let's go back and edit that sketch, and I will do dimension. I'm going to select that arc, I'm going to right click, I'll say dimension type arc length, and I'll accept that. Now because that sketch was already fully defined, the arc length is placed as a reference dimension rather than a driving dimension. Alright, I'll finish that sketch, save it. I'm going to do a new sketch on the YZ plane, and I'm going to draw a horizontal line, 3D, it's actually vertical, and I'll dimension the length of that line is 2.5 inches. And then I'm going to put the midpoint of that line coincident with this point right there. So I need to project that point first. So I'll project geometry, I'll project that point, then I'll do coincident, the midpoint of this line to that point. Notice that that line is fully constrained. I will then draw a line from this point, and I also need to project that point. So let's project this point, and then I'll draw my line from here down to here and back up to there. I'm going to change all of the two lower lines. I'm going to change to construction. I'll leave the upper line as an object line. I'll finish sketch. I'll turn off the visibility of the dimensions on sketch number 2, and then I'm going to create a pattern of the plane that goes through the YZ plane that goes through the center of the part. And so I will do a pattern, rectangular pattern. I'll select that plane as what I want to pattern, and then for the direction I'm going to select the x-axis, and I want to do 7 copies. I want them to be mid-plane, and I will put the distance as this arc length. And actually we don't really need the arc length. Let's do it as this dimension, and let's divide that by 6. So we have a line. We've divided the total, or the distance from here, the 17.75, we divided that into 6 equal divisions. Okay, then I'm going to do a sweep of this line along this curve, and because we have an open profile, it defaults to a surface, so I want that surface going across there. After I did my sweep, I see that this surface comes back over top of itself on each end, and I didn't intend that, so I'm going to edit sketch 1, and I missed this little line when we change that to construction. We need to change this one to construction, and the same one on the other end, change that to construction. Now when I finish sketch on my surface, I don't have that curl going back underneath. So this is going to represent the deck of our bridge, and we need to put some truss members going across. So I'm going to start a 3D sketch, and I'm going to do intersection curve between this plane and that surface, and we'll see that it draws a line across there where that plane intersects that surface. Can do intersection curve again. I just hit the space bar, so I can repeat that command by hitting the space bar between that surface and that plane, space bar between the plane and the surface, space bar again between the plane and the surface, between this plane and the surface, and between this plane and the surface, and between this plane and the surface. I'll finish my 3D sketch. I'm going to drag the end of part marker up before the 3D sketch to do some additional geometry that I forgot. So I'm going to do a point at the end of this curve, and then I'll do another point at the intersection of this curve where this curve pierces through that arc, and I'll just hit the space bar to get that command back here, and then here, space bar between this plane and the intersection with that curve where that curve pierces through that. Let's go ahead and put this one in as well. Alright, now I'll turn off the visibility of sketch 1, and I will drag the end of part marker below the 3D sketch, and then I'm going to edit that 3D sketch, and I'm going to draw a line from this point down to this point and back up to that point. I'll right click, say OK, then spacebar to get the command back from this point to this point, right click, OK, spacebar to get command back. So we'll see how we're going to put all of these triangles in here. Got 3 more to go. Make sure you snap green, and then we can come back across here and connect straight line going from here back to here, back to here. So when we're doing frame analysis, it uses beam elements, which are straight line elements. So we can't use a curve in our frame analysis. We have to represent the curve with straight line beams. So I'll then draw a line from here over to here, over to here, here. Again, be careful that you snap green each time. Select that one, then I need to do one across here. Do the lines across the bottom. Alright, then I need to put a short little piece right here where the edge of the bridge fits over a lip on the testing fixture. So I'll draw a short line from here to here, and I need to do that on each side. And I want to do that as a separate line from this one because it's going to put a separate beam element across that line. And then I'm going to do the same thing on the other side. So from here to the end of this surface, and another line from here to the end of this surface. Once I have those lines in, I'm going to turn off the visibility of the surface body. So I'll hide that, turn the visibility off, and I'm going to put a point at the midpoint of this line and over here at the midpoint of this line. This is 1/8 of an inch from here to here. The diameter of our wire will be 1/8 of an inch, so I'm going to have 1/8 of an inch here, and then it comes over to the edge here and contacts our abutment. So let's put a point at the midpoint right here, and I'm right there. We'll put a line between those 2 points. I'll put a line between here and here. And we'll do the same thing at the other side. Now I want to see if it will actually select a midpoint. It will select a midpoint, so we don't have to create those points there. Now we need to put some cross members going across here. And so I'm going to do a line from the bottom going up to the top and zigzagging back down from to the bottom, back up to the top, to the bottom, back up to the top, and then back to this location. I'll go around to the other side, and I also need to do up to from the bottom up to the top, back down, back up, back down, and back up, and back down. Alright, now I want to put 2 segments in here, so I want to do from here over to here and then down to there. We can't have 2 beams going through each other. We can have one continuous beam and then a half beam and a half beam going this way. So I'm going to draw a line. I want to get this point right here, not that point, not that point. Go from this point to the midpoint of this line, and then down to the bottom, up to the midpoint of this line. Make sure you snap green, up to the top, to the midpoint of this line, down to the bottom, to the midpoint of this line, up to the top, midpoint of this line, down to the bottom, midpoint of this line, and then up to this point, not this one, not this one, to this one. I'll right mouse button, say OK to that side. So I have my truss members on that side. I now need to put those on the other side. And it actually might be easiest to look at this from the top when we're doing this. And so I will draw a line from this point to the midpoint here. And then there's 2 lines here. There's one here. I don't want to get that one by mistake. So I guess that idea of going from the top isn't the best idea. I'm going to go from here and then up to here and then down to the midpoint of this one and then to here to the midpoint of this one and then up to here and then from the to the midpoint here down to here and midpoint here and up. Be careful on the last one. Don't want this point, don't want that point, want this point right there. Okay, so by doing, we did this is one continuous line, and then this is 2 separate lines. So when we put in our beam elements, it's going to put one all the way across, and then a half beam here and a half beam here, where that intersects. I have all of the members of my skeleton. I can hide these work planes, so I can go across here, right click, turn off the visibility of all of these work planes. There's actually a faster way to do this, but for now I'll just do it manually. Alright, so I've turned off all of the work planes. I've turned off the surface body. I have turned off the 2D sketches, so that the only thing visible I have are the 3D sketch. Let's turn off the work points. And I think that we can do that by selecting the first one, holding the shift key down, selecting the last one, right click, turn off the visibility of all of the work points. I'll finish the 3D sketch and save it, and then I'm going to start a new assembly, and I'll place that bridge skeleton revision 1. I want to place it at the origin, so I'll right click, place grounded at origin, and then I'll save my assembly, and I'm going to call this wire bridge fall 19 revision 1. Then I'm going to go into the design tab and I'll do insert frame for standard, ANSI standard for my family round bars at the bottom. The size is 1/8 of an inch. And we're going to, for our placement, we're going to do on edges. So each one of these is an edge rather than going from point to point. And we can select all of these edges with a window. And then we'll select OK and OK to save the files. All of our frame members are created. I will then hide the frame reference model. That's a sketch. And I'll also hide the skeleton. Okay, so here is our frame. We might want to change the color of the frame to some other appearance. And so if I select that geometry, I can put some paint on it, whatever color I want. Now, I probably should avoid colors that would be used in the analysis, but I'm going to go ahead and put yellow on for the color for. Now notice at the end I have these two, and I actually didn't get the distance correct between those because they appear to be overlapping. I thought I had it set where they would just be tangent to each other, but it appears that I actually have them slightly overlapping. I'll then go into frame analysis. I want to create a simulation. We're doing a static analysis. I see that gravity is pointing down, so I don't need to change the direction for gravity. It's pointing in the correct direction. I'm going to put a pin constraint at this point right here in the four corners. So I'll do a pin constraint on this node, a pin constraint on this node, and a pin constraint on the other two nodes at the top. And one more pin constraint right there. And then this node can slide up and down the bridge abutment. So this one fits over, these two fit over the lip of the bridge abutment, but this one can slide up and down. Let's do a floating constraint on this node down here. And I need to set it so that it can slide up and down. So I'm going to drag this angle up now, so it can't go against the abutment. It can't penetrate into the abutment. It can't come away from the abutment with the load pushing down on it, but it can slide up and down the bridge abutment. So I'll select that one, and I'll do the same thing over on this one. So I'll do another floating, and I'll change that angle. I'll select accept that one. Okay, so I've put my constraints in here, and now I want to put a load on here. So let's start out with a small force, and so I'm going to put it at this node in the center of the bridge. And let's start out with I actually don't want to offset distance on there. Let's just go ahead and accept that, and I want to come in here and make a couple of changes. Let's go to frame analysis setting, and for the loads I'm going to leave that as yellow, but for gravity let's change that to brown to represent the earth. And then I'm going to change the size of the glyph, the arrow, and let's do that at 0.5. And there was one other change I wanted to make in here. Let's turn off this heads up display. Alright, so I just made those arrows smaller. I might even make those a little bit smaller. I'm going to go over here to find that load that I put on here, and I'm going to edit that force load, and I want to make sure that it is at 0 on here. So let's put that offset at 0, and I've got 50 pounds. I will then run our simulation. Actually, let's save it before we do that. I'll run our simulation. We'll look at this from the front view, and we see our displacement is about 0.02 of an inch. Now keep in mind that this image is exaggerated. If we put this on actual, we can't really see any displacement in our bridge. And then if we go to the results folder and we go to normal stresses, and I'll select S max, and we see that most of our stress is right over here along this area, and of course the same situation over on the other area. So we can keep increasing the load and calculate the safety factor as we approach a safety factor of 1. So I'll go back to my test assembly, and I will place my revised bridge. I'm going to constrain the XY plane of the revised bridge to the XY plane of the test assembly. So I'll do flush the XY to XY. That'll center it, and then I'll do YZ to YZ, that will center it that way, and then I can drag this down until it contacts the lip on the test assembly. And let's look at this then in section view. So I'm going to cut away part of the test assembly so that we can see, cut away the front half of the test assembly so we can see how this, now I went a little bit too far on this, so I need to actually go a 1/16 of an inch shorter this way and a 1/16 of an inch shorter this way so that it will fit into my test assembly. So that's one good reason for doing 3D modeling, is you can find little mistakes like that before you get the model all welded up and then find out that it won't fit into the test assembly.